sections that we didn't get to cover in class on Thursday. Lesson 24, overlapping triangles, lesson 25, parallel lines, and lesson 26, overlapping right triangles. So let's start over here with overlapping triangles. As you can see, there's a triangle ADE, and inside of it is a triangle ABC. They're overlapping triangles. One's inside of the other triangle. In order to do these overlapping triangle problems, what we're going to do is separate the two triangles out. We're going to have the little triangle ABC, and we're still going to have the big triangle ADE right here. So let's try these with a couple examples and see if we can figure out X and Y. Before we move on, I just want to show you the overlapping triangles. As long as these two lines are parallel in your triangles, you're going to know that this angle and this angle are equal because they're parallel lines cut by a transversal, and we'll get to that in the next lesson. And we also know they both share angle A. So we know angle A is the same, and these two angles are going to be the same. So they're going to be similar triangles. If two angles in one triangle are the same as two angles in another triangle, we know that the two triangles are similar. The reason this helps us is we know that similar triangles, their sides are proportional. So we can solve for parts that are missing. So let's look down here at example 1. We're going to find X and Y. We have an overlapping triangle. We have the little triangle and we have the big triangle. We know that this angle is going to be a shared angle, and we know that this angle is going to be the same as this angle because these are parallel lines cut by a transversal. So what that tells us is the angles on this one and the angles on the big triangle are the same, so the triangles are similar. I'm going to separate these out now. This is what you're going to do for your homework. You're going to separate these out. You're going to write the small triangle with the sides 4, 7, and 9, and you're going to have the big triangle. Now the side on the big triangle, you have to add these together. It's 4 and 6, so that's 10. And you have to add these sides together, which will be X plus 7. And then the bottom is just Y. So now we have two triangles. They're similar. It means their angles are the same. Just fill that in. And this one. If they're similar, that means that their sides are going to be proportional. So I can make proportions. I can say 4 is to 10. 4 is to 10 as, we're going little triangle, big triangle, as 9 is to Y. Just make sure you match up the corresponding sides. 9 is to Y. And I formed a ratio. I'm going to reduce this 4 over 10 just to make our numbers easier to work with. I can reduce that to 2 over 5. You always want to reduce when you can. It makes your numbers smaller and easier to work with. So now we have a fraction we can cross multiply and solve for Y. So we'll cross multiply. We get 2Y equals 45. Divide both sides by 2, and we found Y. Y is 45 over 2. So that's Y. We can fill that in, 45 over 2. We still need to get X, and we're going to do it the same way. We're going to form a proportion. We have our 4 over 10. You could use 9 over 45 halves, but that's really messy. You don't want to do that. So we're going to take our 4 over 10, and I'm going to reduce it right away. Well, let's just put that 4 over 10 equals, now we're going to match this side with this side. 7 over X plus 7. I'm going to reduce right away and make our numbers easier. And once again, we're going to cross multiply. This time you have to take the 2 times the X and the 2 times the 7, the distributive property. So we're going to get 2X plus 14 equals, 5 times 7 is 35. We're going to subtract 14 from both sides, so we're going to get 2X equals 21. Divide both sides by 2, and we get X equals 21 over 2. And these are our two answers. So just remember, when you're doing these overlapping triangles, just separate your triangles out and match your sides. Make sure your angles are going the same direction, and then the sides are going to be proportional. Let's move on to lesson 25, parallel lines. Now, I kind of talked about this in the last example. If you have parallel lines cut by transversal, we learned some things about parallel lines and transversals. Right away when you look at this, you might not think that these sides are parallel. But what they're suggesting in the book is you extend your sides out. And that's what I did right here. I extended my sides to make them parallel lines. And here's our transversal that cuts right through here. And we learned before, if we have parallel lines cut by a transversal, then these alternate angles are going to be equal. So that's how you use parallel lines in your triangles. If you look over here to our first example, if we extend these lines out so that you can see that they're, whoops, that's really bad, parallel lines cut by transversals, we know that the corresponding angles, here's our transversal, our corresponding angles are equal. So that's how we can tell that they're the same. And we would also know that this angle would be equal to this angle by the same way. So that's all there is to the parallel lines. You just want to extend them out and then apply our parallel line and transversal rules that we did before. We have one more example. This is from lesson 26. This is overlapping right triangles. This is similar to the first one that we did, except you're going to notice that these are right triangles that are overlapping. And these lines are parallel too. They're both right angles. So let's look down at example 2. We have overlapping right triangles. So I'm going to do the same thing we did in the first example. I'm going to write the little triangle out here. And then we have our big triangle right here, which I wrote down here. We're going to do the same thing to try to figure out the missing parts, a plus b. These are a little bit more complicated. You can do them different ways. Because it's a right triangle, we can find a using the Pythagorean theorem. A is a leg, this is hypotenuse, a leg and a leg. So we can figure out a by just saying 4 squared plus 6 squared equals a squared. That's the Pythagorean theorem. A squared plus b squared equals c squared. And then we just need to figure it out. 16 plus 36 equals a squared. 52 equals a squared. So we know a equals the square root of 52. So we can find a this way, or, well, we can't really do a proportion because, oh, we could have done a proportion. No, we didn't have enough numbers. We would add 6 over 10, and then this over this would be too many variables. So you can't do proportion. The only way that you can figure out a is by doing the Pythagorean theorem. So now we have a little bit more information. We have a is the square root of 52. So let's see what we can do if we can set up a proportion to figure out this problem. So I think we can. Well, let's figure out c first. We can figure out c. We can say 6 over 10 is equal to 4 over c. Because if they're overlapping right triangles, they're also similar triangles. They both share this, these angles are going to be equal. So we have, and they're going to share this angle. So we know that these two triangles are going to be similar, and therefore they're going to be, the sides are going to be proportional. So let's figure out c next. We can say 6 over 10 equals 4 over c. Again, you can reduce to get it started, so it's 3 over 5, and then cross multiply. So we get 3c equals 20, and c equals 20 over 3. So we have c, I'm going to fill that in. 20 over 3. Now the last thing we have to do is get a plus b. So let's figure that out. We know that a is square root of 52 because we separated them out. This big side is a plus b, so we can make a the square root of 52. And we'll set up one final proportion for this. Just check my notes here. So we're going to get, they don't help me at all, I don't know where we're at. So let's just set up a proportion for these. Let's do square root of 52, I'm going to have to get up here, square root of 52 over, this is the matching side, so it's a square root of 52 plus b equals, And then we can pick either two sides. We can put this over this, or we could put this over this. But since fractions are messy, we're going to go with the 6 over 10. And right away we know we can reduce this, so let's reduce this to 3 over 5. And we have our proportion set up. It doesn't look very nice and neat, especially since I don't have room on my board to write it. But we can, once again, cross multiply. So that's going to be 5 square root of 52 equals, once again, 3 needs to go times both of these because it's a distributive property. So it's going to be 3 square root of 52 plus 3b. Our job is to find b, so we want to subtract 3 square root of 52 from both sides. So we're going to get 2 square root of 52 equals 3b. And then we just need to divide both sides by 3. And our final answer is going to be b equals 2 square root of 52 over 3. It's not a very nice number, but that's our final answer. So we have b is 2 square root of 52 over 3, c is 20 over 3, a is square root of 52. So we got all our variables, a, b, and c. So hopefully you can do these, just separate them out, use the Pythagorean theorem, and then you just set your sides, proportional in a ratio, and solve for each letter. So that's it.